Welcome to ClickMyProject.com. Our project title is Enhancing EEG-Based Classification of Depression Patients Using Spatial Informations. Now we are going to see the project abstract. So, Electroencephalogram, EEG signal-based emotion recognition has acted well interested in recent years and has been broadly adopted in medical, affective computing, and other relevant fields. Depression has becoming a leading mental disorder worldwide. Evidence has shown the subject depression exhibit different spatial responses in neuropsychological signal from the healthy control when they are exposed to positive or negative. We focus our analysis in the main aspects involved in recognition process and compare the work per them. We propose an emotional activation code to demonstrate the activation process of emotion. Objective of this project was to improve the performance of emotion recognition using brain signal by applying a novel and adaptive channel selection method that acknowledges that brain activity has unique behavior that differ from one patient to one another and one emotional state to another. Result shows that our proposed methodology significantly improve the accuracy of classifying depression patients' emotion as positive and negative. Now we are going to see the flow of the project. So in this first we are going to select the data set. So here we are selecting the EEG signal data set, that is called brainwave data set. So we have to select the data set and load into the process. After that we are going to pre-process it. So in the pre-processing we are going to cleaning the data and the encoding label encoder. So after that we are going to scaling the features of a data set and then visualize the data using a seaborn and plotlib. So and then we have to split the data into train and test. After splitting the features as train and test, then we are going to classify using machine learning and deep learning algorithm. In machine learning we are going to using the KNN algorithm to predict the result, and then we are going to use LSTM algorithm, that is a deep learning algorithm, to predict the is known as positive and negative of depression patients. So then prediction results, and the results will be there, and result will be accuracy, precision, recall, F1 score based on the performance matrices. So now we are going to see the running process of the project. So here I have to click this. So the process will start at running. So here it shows the visualization of the KNN classifier algorithm is running here. So the classification algorithm print the classification result and then now calculate the accuracy. So the accuracy of the KNN algorithm is 94, and then this is actually the layers which we are using for LSTM layer, dropout layer and dense layer. So dropout and dense layer is a hidden layer for this. So now the approaches are calculating. And the LSTM final accuracy will be 94. This is actually a evaluation. So this is actually a train test result and the evaluation result is this. So this is a classification report for LSTM and this is a confusion matrix of LSTM. So here it shows the count of negative, neutral and positive thing in the data set based on the EEG signals. So this is the future of that. This is the data set of EEG signal. So this is train data. Test data. KNN prediction, LSTM prediction is this. So finally KNN gives the 94 point something accuracy of it, and this is also 94.14 something. LSTM shows the result. Thank you for watching the video.